My name is Naba Tanziranya, and I've designed a C program that describes the quadratic formula and how it works. Yes, and differentiates between the real and the complex roots. So here, the first line and second line describe that these are directives that include the standard input and output and the math library, that's for the second line, respectively. Yes, so the third, fourth, and fifth line declare that A, B, and C are integer variables, and the sixth and seventh line are where we store the coefficients and roots. Yes. So my eighth line is where we have the function, and the first line says that the function definition for the calculate function that takes three integer parameters, that's integer A, integer B, and integer C. Then my ninth line shows that I'm calculating the determinant of the quadratic equation that states that b squared minus 4ac. Then the 10th line, yes, checks if the roots are real or complex. That is, but before, yes, the 10th line shows that the determinant is got by, for each of the integers, the numbers x1 and x2, is got by negative b plus the square root. The square root, this is how it's stated in the C program, yes. So for positive, a positive is a real root and the negative is a complex root, yes. And I used the printf, and it states that x1 is equal to the percentage sign, then dot 2f. This shows that my program is going to give the roots to two decimal places. That's why I use the 2f. So it states that the float has to be given to two decimal places. Then the n is to enable me to go to the next line, yes. Or else, if the digits I've put, let me say I put 20 or something, that will give me a complex root. This will show that if I'm given something like this, or else I'm going to get complex roots, yes. Then we proceed to the main function. A main function can appear either before or after, yes. In the main function is where the program execution begins, yes. So here, this printf enables me to print out, to enter a value, any value that is given. And in the question they told us that a cannot be 0. So the first line and second, third, and fourth, fifth of the main function is showing that if I enter a value of a, and here it is to specify that it's an integer, then in the address of a, if a is equal to 0, I'm going to print out that a can't be 0. So in my program, when I enter, let me say 0, it's going to bring out a can't be 0, and the program will finish. That is the use of the return. The program will finish there and then, yes. So that's for only a as given in the question. Then I'll proceed to print out the value and enter the value of b, and do the same thing as I did before for a, but here they didn't specify what b can be. I assume B can be 0 or C can be 0, but as long as A is not 0, because if A is 0, there is no use of the quadratic equation. It will cease to be a quadratic equation. So this will prompt me to enter the value of C, enter the value of B, then I'll call the function again. Like in my 8th line, I'll call the function again and then return to 0. Then I'll control and save, then execute, compile and run my code. So here I can enter the value of A. Let me say the value of A is 1. I enter. The value of B is 20. I enter. The value of C is 5. Enter. It will give me the two values, the two roots of whatever equation I've inserted. Yes. Then let's assume, let me compile and run again. If I enter a value like 0, enter, they show you that A can't be 0. That's immediately where the function ends. It doesn't continue to tell you enter the value of B or enter the value of C. A can't be 0, so it ceases to be a quadratic equation. Then let me try one where let me say the value is 5, 20, 11. Yes, it will give me the roots. So it continues. But in a situation where I enter the roots and they give me something complex, in the end here it will show that the roots are complex, like I stated here. It will show that the roots are complex and there is no way we are going to work out any complex roots. Yeah, so that indicates an successful execution of the program given. Yes.